Hi everyone, this is James T. from BSc 3B Science, CBS UA Pili Campus, and welcome to Quantum Mechanics. Today we are going through the equation of famous French scientist Louis de Broglie. In 1924, Louis de Broglie presented this thesis, proposing that electrons have properties of both waves and particles like light. He rearranged the terms of Planck-Einstein relation to apply to all types of matter. De Broglie derived an equation that described the wave nature of a particle. Particularly, the wavelength lambda of any moving object is given by lambda is equal to h over mv, where the lambda is the wavelength, h is the Planck's constant, m is the mass of the particle, and it is expressed in kilogram, while v is the velocity or speed of the particle in meter per second. Let us first discuss how the de Broglie equation are being derived. Using the equation for the photoelectric effect relating the amount of energy to the frequency, which is E equals to h and f, where the h is the Planck's constant and f or the nu is the frequency of the wave. And also, the relativistic momentum of the photon is ρ equals to E over c, where E is the photon energy and c is the speed of light. And it can be derived into E equals to ρ and c. Since they both talking about the energy, we can say that E equals to hf and E equals to ρ and c. We can say that hf is also equals to ρ and c. In this equation, since f is equal to c over the lambda, we can get h multiplied by c over lambda equals to ρ and c. Likewise, we can equate this equation into hc is equal to lambda ρ and c. Finally, we can remove ρ and c by dividing it to both sides to get the wavelength. We can cancel out and we get lambda equals to h over the ρ. Since ρ equals to m multiplied by the v, we can get the de Broglie wavelength into lambda equals to h over m multiplied by the v. Let us take this equation into problem. What is the de Broglie wavelength of an athlete with a mass of 75 kg moving with a speed of 10 meters per second? To solve the problem, we get first the given. M or the mass is 75 kg. V or the velocity, which is 10 meters per second. And the Planck's constant, 6.626 times 10 raised to negative 34 joules second. We use the formula for the de Broglie wavelength, lambda equals to h over m multiplied by v. We can now substitute the values. 6.626 times 10 raised to negative 34 joule seconds, or convert the value for the joule, which is kilogram meters squared over second squared multiplied by second, in order to cancel out the other values. Divided by 75 kilogram multiplied to the velocity, which is 10 meters per second. The result is equals to 6.626 times 10 raised to negative 34 meter, as we cancel out kilogram, seconds, and meter divided by 750. Finally, the wavelength of an athlete with 75 kg mass moving 10 meters per second is equal to 8.834 times 10 raised to negative 37 meter. Particles or matter with great mass, just like the athlete, we cannot see its wavelength as it is very small that cannot be seen by our naked eye. However, it is evident that matter with velocity can act as a wave, as it has wavelength, which is the property of a wave. It is what Louis de Broglie trying to tell us through his equation. Likewise, the de Broglie equation is not applicable to the matter with mass, which is not moving or doesn't have velocity. The de Broglie equation allows us to calculate the wavelength of the moving matter or particles. Since then, this equation has been shown to apply to elementary particles, neutral atoms, and molecules. That was the de Broglie equation, and see you on the next lesson about quantum mechanics.